Welcome to part 2 of the lecture on functions. Now we are going to look at mainly function parameters or arguments to functions. We are going to look at how we pass those arguments or parameters to a function, how we can use it in a function, and what it means when we pass arguments or parameters into a function. At the end of part 1 of the lecture about functions, we briefly mentioned about the exercise that I encourage you to think about and implement. Right? It was to write a program to compute the circumference and the area of a circle given the radius. Right? So the user inputs the radius and the program has to compute the circumference of the circle and the area of the circle. So let's see how to implement this in Python, and let's understand how functions can help such implementations. So there are several possible ways of achieving what we wanted to calculate, the circumference and the area of a circle given the radius. Right? There are many ways of writing a program to calculate those. So this is one implementation. Right? So let's try to understand what it does exactly line by line. So the first line, we have defined the constant pi. Right? So pi is a constant. So this is the naming convention that we use in Python. We use all capitals for constants. Right? So we have defined pi equals 3.141, and we'll be using this constant in the calculations of area and circumference. This should remind you that okay, this is a function. It starts with def, right? Area. It calculates the area. That's a name we give so that we know it calculates the area. The input argument or input parameter is r, which we input the radius, right? R is the radius. We have a docstring, calculate the area of a circle given the radius, right? And it returns pi r squared, right? There are different ways of writing r squared. This is an easy way of writing r squared. R into r is r squared, right? So pi r squared is returned when you call area. Similarly, we have function definition for calculating the circumference of the circle, right? Def circumference. Input is again r, the radius. We have a docstring explaining what the function does, calculate the circumference of a circle given the radius, and it returns 2 pi r, right? 2 pi r is the circumference of a circle of radius r, right? So these two functions are now defined. In the rest of the program, now we have to call the function, but before calling the function we have to ask the user for the radius, right? So it's a floating point value, right? It can be some decimal points are typically available. So we say enter radius, we take the input, right? And we store it in r. Okay, let's see how we can get the area calculated. So there are different ways of continuing from this point. So now for area, I calculate the area by calling the function area, pass the radius r, then a will get the area, right? Because area function returns the area of the circle. Then in the next line I print a, right? That should be clear. The following line, without calling the function outside and then assigning into a variable like this, I directly call it inside the print statement, right? So so here we have a, here instead we have circumference r. I directly call the function inside the print statement within the braces, right? So that's another way of printing the value directly by calling it inside the function. So the return value of this function is printed here as the circumference. If you want to see the line by line execution of this program in the Python interpreter, you can go to this code visualization. Right, now it's again your turn to write a Python program to achieve the following. The exercise 9.03, write a function to find out if a given number is a prime number. Right, so the program should ask the user for an input, a number, and then the program should check if that number is a prime number and say if it is a prime number or not. Right, so think about what kind of function call you would like to use and what kind of function you have to write, right, and then implement it. Right, so think about it, implement it. In Python, we are dealing with objects, right? So if you define a certain list or some variable or even a function, right? Even a function is seen as an object in Python. So when we pass an argument or a parameter into a function, we are passing an object by reference, right? So we are not passing the object itself. We are not passing the value of the object either. We are passing a reference to that object in the function. So next few slides we'll be looking at an example which is shown below in the slide below. So if you change what a parameter refers to within a function, the change can reflect in the calling function only if the reference was to a mutable object, depending on how you are changing it. Right, so if a mutable object, a reference to a mutable object is passed into a function, and that function, inside the function that passed the object, the reference, via the reference, if it is changed and the object is mutable, then the changes will be reflected in the calling function, right? Not the called. So within the called function you are changing it, and the object gets updated in the calling function as well. We'll look at it quite closely in the next few slides, so don't worry if you don't fully understand the whole picture at the point right now. So this is the example we are going to analyze for this for studying pass by object reference. So here we have this function def change me. It takes one argument, so it's a list, my list in function, right? So this function, it changes a passed list into this function, right, inside this function actually. Right, so, and it's called here, so we first defined a list, my list, and then we print the values of that list. So don't worry about this line right now, we will talk about it later on. And then we call this change me function, passing this list that we created, right? Inside this function we are appending something into that list, right? And then we try to print it afterwards. After changing, we are trying to print the same list. So now look, the argument here is to change me is my list, right? So we are printing my list. So if something has happened to my list after calling this function, we will see it in this print statement, right? So look, let's see how things work in memory, right? So this list, my list, when you have defined it, so it will be a list object in memory, right? So my list contains a reference to it, and when you pass it to change me, when you pass by reference using change me, this my list in func, that reference points to the same reference that already points to the list object. That's the thing to understand, right? So this myList_infunc, since we pass change me to it, since we pass myList to that change me, that contains the same reference, that contains the reference to the same object, right, that we defined earlier. So that's what we pass. We pass the reference to that object into that function change me. Okay. So let's look at the expected output of the same example. So here's the definition of the function def change me. Right, whatever the input list, this function appends another list to it and then prints that list inside the function and it returns, right? That's the task of this function. Now we are calling it. This is the calling part. myList, right? We initialize a list. We then print the values before calling the function myList. So it's now printed here, right? Values before calling the function 10, 20, 30. There are no surprises here. Then we call the function change me. We pass this myList, right? Within that, as we see it gets appended and then it gets printed. Values inside the function we have 10, 20, 30 as before, and then we have this appended part 1, 2, 3, 4, right? We see it here. Then it returns, and then so that's the one we called, right? Then we have again another print statement, values after and outside the function. We print myList. So if there are any updates, we see it there. Look, 10, 20, 30, and then 1, 2, 3, 4. So this list that we have defined here in the calling part has been updated by this function, right? Because we pass this function by reference, and it's a mutable object. A list is a mutable object, so it gets updated. Let's see in the Python tutor code visualization, step by step, what happens inside.
So here I have the same function in Python tutor. I'm not going to explain the UI of the Python tutor because I assume that you are already familiar with it. So here I have the function change me, which takes in a myList_infunc object, parameter, and inside this function I'm appending a list to the parameter that is passed to that function. So I'm assuming that this parameter is also going to be a list because I'm calling the append function of the list object, right? And then I print values inside the function and then return, right? So let's execute this program and see how the memory management happens and also what are the outputs of the execution of this program. And so at the beginning, in the global frame or the global memory, Python creates a change me reference to the change me function, which is the function object change me myList_in function, and then there's a placeholder referring this function itself, right? So whenever someone calls this function, Python knows to go to this location and then execute the function itself, right? So next I have a list object called myList. So in the global memory that is also created, there's a myList object and it is referring to this list itself, which contains 10, 20 and 30. And then I print the values before calling the function. You can see in the output these values are printed, and then what I am doing is I am calling the change me function and passing this myList variable that I have created as the parameter for this function. Okay, so when I do that, go into the function, you can see that the myList_in function, the parameter that is inside the change me function, is also referring to the same myList object that that was being referred by the myList. So this is what we call as the pass by object reference. So the reference to this object is what is passed. So when we go inside the function, now you have you have myList_in function which is referring to this list itself. So you are trying to append something into this list. So what you are trying to append is 1, 2, 3, 4, another list, right? So if it is another list, then that list also has to be created in the memory. So that is exactly what happens. So you can see that another list has been created in a separate location in the memory, and the appending itself is adding another object to a list. So what happens is in the appending function call, this other list, the 1 2 3 4 list gets appended into the original lists that we had, so which is being referred by the mylist variable as well as the mylistin function parameter. You can see that that means if you try to access this mylist variable, then it should also show this output. So let's see whether that indeed happens, right? So I'm going to return. So it's not returning anything, but that doesn't mean that object has changed. So the actual list object that was created has now changed in the memory. So when I try to print that, we can see that that is what is indeed reflected in the execution of this program. So inside the function, obviously, because inside the function this is what is expected, and even outside the function, because I have changed the actual object itself, and you can see that the values have changed, right? So this is an example of pass by object reference in Python.
Let's try to understand this pass by object reference with another slightly different example. So in this case, it might look very similar to the one we ran before, right? It looks very similar to the program we ran before, but there's a subtle difference, very important difference. Here we again have change me, right? The function change me having an argument called mylistinfunc. But look at the change here, the difference from the previous slide. So mylistinfunc is assigned 1 2 3 4. A new list is assigned to this mylistinfunc. So here again we print the values inside the function. This mylistinfunc is printed again, right? We, like before, we initialize a list outside. So outside the function scope, in the main scope, we have mylist, define a new list. We print the list. We call change me. This part is called, where inside that we print whatever that's changed inside the function, and then we outside the function, after the function returns, after the function call returns, we print mylist again. Now see what's different from before. Values before calling the function 10 20 30, right? It's reasonable. Values inside the function. So here inside the function, so we assign this 1 2 3 4 to mylistinfunc, and we print that. So 1 2 3 4 is printed. Okay, but when we print it again outside after returning into the main function, when we print it outside mylist, it says 10 20 30. It does not say 1 2 3 4. So let's understand how that happens, right? Why it did not follow the same pattern as before, by observing it in our code visualization in the step-by-step run.
So this is the Python tutor example of the same example program that we looked at earlier. So you can see in this we have the change me function, which is getting a parameter mylistin function and then assigning a new list into that parameter and then printing that and then returning. And so in the main program I have a list object, and then I print what is inside that object before calling the function, and then I call the function with that object and then print what is in the object itself after calling the function to see what has happened. So let's go step by step inside the execution of this program to understand what is going on here. So first, similar to last time, when I define the change me function, it gets a position in the memory referring to the function object itself, which contains the change me function and the mylistinfunc parameter that is passed to that function. And then I create another list object called mylist containing 10 20 and 30, and then I print the values of that mylist object. As you can see, values before calling the function are 10 20 and 30, and then I call the function change me with that mylist object. So when I do that, you can see the parameter mylistinfunc of the change me function is referring to the same object that the mylist is referring. You can see they are both pointing to the same object which contains 10 20 and 30. So what happens inside the function is I'm creating another list called 1 2 3 4 and then assigning that list into this myListIn function object, the parameter. You can see when I do that, what happens is another new list is created, and when I assign that into myListIn function parameter, the pointer that was previously pointing to the myList object gets changed to the new list that I am assigning to. You can see this is what happens inside the execution of this program. So this is different to what it was doing before when I try to append the referred list that was given to the function. You can see now because of this the myList object does not change, and so it remains to contain the values 10, 20 and 30. So when I print the values inside the function of this myListIn function variable or the parameter, you can see obviously it should print 1 2 3 4 because that is what the value, what are the values that are containing inside this parameter, right? So that is what is reflected here. Values inside the function are 1 2 3 4, and then I return nothing to the main program, and in the main program now there's no myListIn function object or the 1 2 3 4 list that was there inside the function. Now all of that has gone. What remains is the myList object, which is referring to 10 20 and 30. So when I print it, as expected, it is printing 10 20 and 30. So I hope that you understand the difference between passing values into functions and what it means to pass by object reference.
Here is another exercise for you to try out. First, read the question, right? What would the output of the following code segment be? Right? Would it be the first one or the second one or the third one? Try to reason about it. Try to understand based on what you have learned so far. Try to reason why you think a particular output is the one you expect, and then run the code in idle, or you can try the code visualizer and see what goes on and see if you got it right. Don't worry if you got it wrong, but try to learn from that. And after that, another exercise for you to try out with a small variation to what you saw in the previous slide. Again, try to first guess or estimate what the output would be, right? 10 or 100 or 110, and after justifying the answer to yourself, run it in idle or in a code visualizer. Try to then understand, try to see what the actual output is, and then if you got it right, great. If you got it wrong, don't worry, learn from it so that your knowledge of how functions are called gets clearer. So you know the basics, the fundamentals of how to write a function, how to call a function, what happens when you pass an object by reference, right? Different types of objects behave differently. There's obviously more to learn, but you know the fundamentals, and you could get better with more practice. One important thing to learn besides the fundamentals is how to write a good function as a good programmer, good software engineer, right? A good function will have just one well-defined task, right? It's a very specific thing, a task that the function is supposed to do. And when you have a well-defined task for that function, it's easy to name it also. You can give the name, but the name directly suggests what task that function is doing. And inside the function, the task should be done well in an efficient way, right? That's more the programming skill and algorithms knowledge and data structures. Everything comes into that, right? Apart from that, so certain organizations follow different kinds of coding styles, right? And there are some general coding styles for Python as well. So try to use those guides as well, right? That includes naming of functions and how to write doc strings, right? Another thing is the interface to the program. That means, so in a complex program, you might think of a complex function that requires hundreds of parameters. That's not a good design, That's not a good design for the function. So try to make the passing of arguments minimum. So maybe use a list or another custom data structure, right, to pass values efficiently. Pass by reference, obviously, but yeah, pass the arguments efficiently. So then that's what we call a narrow interface to the rest of the program, right? As opposed to having hundreds of arguments to be passed. So becoming a better programmer, right? Becoming a better programmer, a better software engineer requires lots of practice, right? So just listening to a lecture or reading a book or tutorial does not get you much far, right? It's just a starting point. So you really have to practice, right? Start coding immediately. Right? So you have your labs, but that's not enough. Try to go way beyond labs. There are so many other platforms which are freely available for you to try out, right, to improve your experience and skill. So HackerRank and TopCoder are freely available coding platforms, so you can start at a beginner level and keep solving programming problems, and you can reach advanced levels, right? So HackerRank is used for recruitment as well. Certain tech organizations, they give a live coding task sometimes on HackerRank. So these are very useful platforms. You could start using them right now. And then we have listed a couple of coding competitions that you could try. So already IEEE Extreme typically happens every year. So watch out for that. Look for it. Search for IEEE Extreme. You can form a team, a 3-member team, and then make a submission, right? And we have Mora Extreme as well. It's organized by the University of Moratu. And then so a longer version of coding. So Google Summer of Code is not necessarily a competition. It's like a 3-month long exercise where you, I think, potentially also get you can get paid also, right? It's like a small summer job, but it needs you to be like a better programmer already, right? There's a small recruitment part to it as well for 3 months, and they invite you to work on an important open source project, right? That's also highly encouraged. So yeah, try to get yourself busy with programming. That's the only way to become a programmer.